Hi guys, welcome to video 3, Chemical Formulas. This video covers standard 8.5D from your unit plan. If you have your unit plan with you, you may want to take a look at the standard and the learning objectives for this video before you watch it. You're expected to recognize that chemical formulas are used to identify substances, and you're expected to determine the number of atoms of each element in a chemical formula containing subscripts. By the end of this video, you'll be able to do just that. Go ahead and pause the video and write down the essential questions in your interactive notebook. So you've already probably figured out that chemical formulas represent substances. The chemical formula we're all most familiar with is H2O, the formula for water. A chemical formula has chemical symbols, the symbols on the periodic table that represent elements, as well as numbers. We'll talk about the numbers in a second, but first let's talk about the chemical symbols. All formulas represent molecules, two or more atoms that are bonded together. The molecule is an element if only one chemical symbol is present, like this molecule of chlorine. Molecules that are only two atoms of the same element have a special name: diatomic molecules. They're kind of the exception because most molecules are made of more than one kind of element, like water, making them compounds. You can tell how many elements are in a molecule by counting the number of chemical symbols in the formula for that substance. Water has two symbols, so it's a substance made up of two elements, hydrogen and oxygen. Now let's talk numbers. You will encounter two different numbers when you're dealing with chemical formulas. These little numbers here are called subscripts. They tell you how many atoms of an element there are in one molecule of that substance. They only apply to the element to the left of the subscript. So this guy has nothing to do with oxygen. It's just letting us know that there are two hydrogen atoms in one molecule of water. If there is no subscript, like over here, then that means there is only one atom of that element in a molecule of the substance. That's the case for oxygen. If it helps you, you can always write in a 1 to remind yourself that that atom is there. That may be more helpful as you deal with larger chemical formulas. This one's pretty simple. Coefficients are the large numbers in front of a chemical formula, this guy. They represent the total number of molecules of that substance. So each molecule of water has two hydrogen and one oxygen atom. Let's draw a quick model of one molecule of water. We'll use blue for hydrogen, and we'll use red for our big oxygen atom here. Okay, there we go. Now, this coefficient tells us that there are two molecules. So if we draw another one, the coefficient will double the number of atoms in this chemical formula. Let's take a closer look at how to count atoms in each chemical formula. When you're counting atoms in a chemical formula, it's really important to stay organized. I like to do that with a T-chart, like this, that lists the elements found in the formula on the left and the number of atoms of each element in the formula on the right. Let's start with calcium chloride. Calcium chloride is a compound you've worked with. It reacts exothermically with water, releasing a lot of heat during the chemical reaction. There are two elements in this formula: calcium, chemical symbol Ca, and chlorine, chemical symbol Cl. Calcium doesn't have a subscript, which means there is only one atom of calcium. If you want, you can write a 1 in to help you out. Chlorine has a subscript of 2, which means there are two chlorine atoms in each molecule of calcium chloride. Some of you are very visual, and the best way for you to stay organized is to draw the molecule itself. That's easy enough. We'll draw a purple dot for the calcium atom and two green dots for our chlorine atoms. And voila, we have one molecule of calcium chloride. There is no coefficient in this formula, so it just represents one molecule of calcium chloride, and we can stop there. Now let's tackle water because it has a coefficient. We've already looked at water, but let's use the T-chart to break down this formula and count atoms. There are two chemical symbols, H and O. So we have two elements, hydrogen and oxygen. Hydrogen has a subscript of 2, so there are 2 atoms of hydrogen in each water molecule. There's just one oxygen atom in each water molecule because it has no subscript by the chemical symbol O. Remember, you can always add it if it helps you out. Wait, we're not done. Now we have a coefficient. This coefficient means the formula represents 2 molecules of water. It doubles all of our atoms. So let's multiply these by 2. There. This formula represents 2 molecules of a compound, water, with 2 elements in it, totaling 4 hydrogen atoms and 2 oxygen atoms. That's a grand total of 6 atoms in this chemical formula. Let's look at this last one. This is sulfuric acid. It has 3 elements, hydrogen, sulfur, and oxygen. Each molecule of sulfuric acid has 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. We can tell by the subscripts. This formula, though, represents 3 molecules. So let's multiply. That gives us a total of 6 hydrogen atoms, 3 sulfur atoms, and 12 oxygen atoms. The grand total of atoms in this formula comes out to 21, because 6 plus 3 plus 12 gives us all of the atoms in all of the molecules for sulfuric acid. Some chemical formulas contain parentheses. It's not a big deal. Don't let it throw you off. In a math class, what do you do with a number that is outside of a parentheses? You distribute it to whatever is in the parentheses, or you multiply by each of the terms in the parentheses. It's the same with a chemical formula. A subscript found outside of a parentheses is distributed or applied to all of the elements in the parentheses. After you've distributed, you just complete your T-chart as normal. So our chemical formula in this example has 3 elements. It has barium and nitrogen and oxygen. If there was no subscript, we would say that there are 3 oxygen atoms. But since we've distributed in, we multiply the 3 oxygen atoms by 2 to get a total of 6 oxygen atoms. If there was no parentheses, we would say there is 1 nitrogen atom. But since there is a parentheses with a subscript of 2 outside, we multiply that 1 nitrogen atom by 2 to say that there are 2 atoms of nitrogen in each molecule of this substance. Now, one thing that you do not do is take a subscript that is outside of a parentheses and apply it to elements that are not in the parentheses. That will give you an incorrect count of atoms. So for barium, we do just have 1 atom in each molecule of this substance. Now, we have one more thing to deal with. We have a coefficient, which means this chemical formula represents 2 molecules of this substance. So we need to take our final count and multiply it by 2, because all of the atoms are doubled since we're dealing with 2 molecules. That gives us a total of 2 barium atoms and 4 nitrogen atoms and 12 oxygen atoms. If we were counting all of the atoms in this chemical formula, that would give us a grand total of 18 atoms.